A particular type of two-dimensional collision occurs when the two particles are connected with a string. So this is the first particle. It is connected with a string to the second particle. So let's say this is particle A and let us say this is particle B. They are kept on a horizontal surface and we are looking at the horizontal surface from the top view. Now let us say this particle B is given a velocity u towards the right hand side. So this is the situation before collision. So after a while, what is going to happen? After a while, the string will become taut. So when the string becomes taut, then at that point particle A will be over here. Let's say particle, so this is the taut string now. This is the taut string. This is particle A that's present at one end of the string, and particle B is present at this end. So just before the string got taut, particle B had a velocity u over here towards the right hand side, and just after the string gets taut, then particle B has two components of velocity. One happens to be along the taut string and one happens to be perpendicular to the taut string. So these are the two components of velocity for particle B. So let us say this is VB in X direction and this, let us say, is VB in Y direction. So such kind of collisions can be termed as string collisions. So in string collisions, what we need to understand is momentum is going to be conserved along the length of the string, because the length of the string is constant, or it's a constrained kind of motion. So after collision, let us say VBX is the velocity of particle B along the X direction. Then not only is the momentum conserved along the X direction, but it also implies that velocity of particle A along the X direction is going to be the same as VBX. So the velocity becomes the same along the string. So this is along the string direction. So the velocity is going to become the same along the string. Why? Because the string is taut. Since the string is taut, it cannot expand in length, and since it cannot expand in length, both the ends of the string have to move at the same velocity. Otherwise the string needs to expand or contract in length if both the ends are moving with different velocities. So that is the reason why in string collisions it is very simple to understand. If let us say this is angle theta, then the initial velocity of point B along the X direction over here, which happens to be, the X direction happens to be along the string, so this direction we are taking as X direction, and perpendicular to the string happens to be the Y direction. So initial velocity u along the X direction happens to be u cos theta. So mass of B into u cos theta happens to be the initial momentum of the particle B along the string. So as per the logic of the string remaining taut, the velocity of both the particle A and the particle B happens to be equal to the same value after the collision. So that means this is going to be equal to mass of A into velocity of B in X direction plus mass of B into velocity of B in the X direction. So velocity of A in the X direction and velocity of B in the X direction are the same after collision along the string. So this is one equation that we get for string collisions, and another equation that we get is perpendicular to the string direction. There also momentum conservation happens. So mb u sine theta is the initial momentum along the bidirection. Over here, this is going to be equal to mb vb in the bidirection. So here you get only two unknowns. You get two equations and two unknowns. So this is along the bidirection, and hence we can solve the entire system. So this needs to be understood in case of string collisions, that the velocity after collision for both the particles is going to be the same along the string, because the length of the string is constant. This is an inextensible string, and momentum is conserved along the length of the string as well as perpendicular to the length of the string. So these are the two equations that will be used to solve string collision like problems.